this video, we'll be building SQL queries using the JavaScript Knex library. So by the end of the lesson, you will be able to set up the Knex library and use it to write select, insert, update, and delete statements. Let's take a look at the docs. You can find the Knex docs at Knex.js.org. One little note about these docs is that some of the syntax is slightly different depending on what database management system you're using. So you might want to go ahead and select SQLite 3 from the drop-down over in the corner. Now there's a lot of different things we can do with Knex, and we'll take a look at a few different features in this library by the end of the sprint. But for this video, we're most interested in the Query Builder feature. So we'll be taking a look at some of the different tools we can use within this Query Builder. In order to really get started with Knex, we're going to need an empty repository. I'm going to start by creating an empty folder. And opening it in VS Code. Now there's two steps we want to take whenever we're starting a brand new repository. First, I'm going to initialize it as a Git repo, and then you can run either yarn init or npm init, and I use the -y flag so that all the questions are automatically answered. So you'll want to pause the video at this point and go ahead and create a new folder and initialize the repository and get started with yarn or npm as well. Once you finish that, the next step is that we need a database of some sort. If we're really going to see Knex in action, we need some sort of database for it to connect to. We can create a new database using SQLite Studio. Make sure that you're actually saving this within the repository you just created. We can see it appear over here in VS Code. Now I'm going to create one table within here. We'll call this users. I'll give it a primary key. And I'll just create one column called name. And that will be a string. And then we can use the check mark to commit this table to our new database. So now would be a good time to pause the video, create this database, and set up a user table with this following schema. Once you're done with that, we should just put a few bits of sample data within here so that we have something to work with. All right, you can come up with whatever names you'd like, but just put a few pieces of sample data in our database. So that's the setup we really need to get off the ground. We need to create an empty directory, initialize it as a Git repo, and get started with yarn or npm, and then jump on over to SQLite Studio, create a new database that's actually saved within our repository, create a table for that database, and then enter a few bits of data in there. So once you guys are caught up, meet me over in VS Code and we will start to work with Knex. In order to get started with Knex, we'll need to add two libraries to this repo. The first library is the actual Knex library, which is pretty obvious. But the second one is a little easier to forget. It's called SQLite 3, and it's a library that's going to allow Knex to interface specifically with a SQLite database. So get in the habit of whenever you're adding Knex, also add this SQLite 3 library, assuming, of course, you're working with a SQLite 3 database. All right, finally, the very last setup step, I'm going to create an Index.js, just so we have somewhere to work. Now we're ready to get started with Knex. To start, I'm going to, of course, require Knex and save it into this variable. Now, like many of these libraries, Knex is an executable. So this, when we execute it, will return to us an object that we can use to build these query statements. Knex requires a config object. The purpose of this config object is to let the library know what type of database we're working with and any settings we want. So let's go ahead and create that config object. We need to start by specifying what database management system we're working with. So we always want client SQLite 3. Now this line of code is contingent on that library we added. So this would fail if we hadn't added that SQLite 3 library in. The next thing we need to tell Knex is where to find the database, and we use that using something called connection. In the case of SQLite, all we need to specify is where the file lives. So file name, and then the path to the file. The final thing we're going to need to put in is something called use null as default, and set that equal to true. This is another SQLite specific issue. We don't need to get into the weeds here, but this will prevent crashes when we're using SQLite 3 with Knex. So these are the 3 keys you need to put in your config object to get off the ground with Knex. We start off by saying which database management system we're using. Then we go ahead and specify where to find the actual database, in this case just the path to the actual file. And then finally, this use null as default setting, which is important whenever we're working with SQLite. So we can call Knex, pass in the config object, and it will return something called DB, or you can call this different things. Generally, we'll see it called DB. And this is going to be the object that all of our query building methods live on. So this is the key. Oftentimes, you might see this DB object exported so that you can use your query building anywhere in the code base. But for this video, we'll go ahead and just do everything in one file. So go ahead and pause the video, get caught up here, and then we'll start to build some query statements. So now that we have Knex set up, we're free to build SQL queries in JavaScript. The best way to organize our SQL statements is actually to create database helper methods. That should be very familiar to you because you're used to using these to write your endpoints. However, now we're switching gears and we're actually going to be writing helper methods using Knex queries ourselves. So let's go ahead and start with the basics. This will be used to find all of the entries within our user's database. And it turns out that the syntax for this is extremely easy. This is the most basic thing that we can do in Knex. So I've taken this DB object and I've actually executed it and passed in the name of the table. This is equivalent to select all from users. So this is the Knex version of this SQL statement. And then we can go ahead and just return this. And this will actually resolve to a promise. So all of these Knex methods are going to resolve to promises. Now let's write a slight variation of the find. Find by ID. What we're really looking for here is select all from users where ID equals whatever the ID is. So we can start with this basic select and then chain on a where. Now Knex has a few different ways of doing basically everything. So I'll show you two different ways to work with the where statement. One way is that I can pass in the ID and then as the second parameter the actual value, which is whichever ID is being passed in by whoever's using this method. Another option is I can pass in an actual object. So both syntaxes are correct. I can either pass in an object with the field I'm interested in or two different arguments. Go ahead and catch up with these two helper methods, and then we want to actually test them and see if they work. I'm going to go ahead and create an asynchronous execute function. This will just give me a place to test out these helper methods. What I'm doing here with this execute function is I'm just kind of hacking in so that I can easily test these out without having to write endpoints. This might be a good thing to try out when you're writing these types of things on the homework. So within here, I want to call find. And I expect that to resolve to a list of users. Now we would of course want to wrap this in a try statement, but just for time's sake, I'm going to go ahead and skip that step. And then I will call execute at the bottom of my file, and we can run this file. So go ahead and create your execute function, actually execute this find helper, and then call execute at the bottom of the file. Now we can actually use Node to run this file and test out manually if these helpers are working or not. We will, of course, need to console log users if we want to see anything. And we see logged to the console are 3 users from the database. So it looks like find is working as intended. Let's try find by ID instead. Looks like that one is also working. The next thing I want to play with is an insert statement. So we'll create an add helper method. We start off with this DB users. As we saw up here, on its own in Knex, this statement will default to a select. But it's also the way we start a lot of other queries. So in order to turn this into an insert, I just chain on the method insert. And then I can pass in an object containing information about my users. So we're of course assuming that that's what's happening here. So we pass in the user object coming in from whoever's using this helper method. And that's it. DB, pass in the table name, dot insert, and then we pass in an object containing the information. So let's test that out. So I've passed in an object containing the name field. Let's run execute. Now I haven't console logged anything in this case, but we can go ahead and check in SQLite Studio and see that Amelia has in fact been added. There are a couple more things I want to show you about this insert statement in Knex. The first is I want to show you what happens if we add in a field that doesn't exist here. Now, because I didn't put a try block in here, it went ahead and actually threw the error. But we see that there's actually a SQLite error that appears here. Table users has no column named password. If we try to put faulty data into the database, it's going to reject it. So this is a big reason why we always need a catch. These database functions that we're running with Knex are not guaranteed to work. If we try to do something strange, they will throw errors. So this is why we always need tries and catches within our endpoints. The last thing I want to show you about this is what this insert statement actually resolves to by default. So this will actually resolve to the ID of the newly created record. So we see that we actually get the ID, a single ID within an array. And just as a reminder, within SQL, this is what our insert statement would look like. With this, of course, being whatever name value is coming in as an argument within our add function. So I'd like you guys to now pause the video, get caught up with this add helper, and then go ahead and add a new user into your user database. You can confirm that it's there either using SQLite Studio or by using our find or find by ID helper methods. The next method I want to look at is an update. Generally speaking, update helper methods specifically update information based on the primary key or the ID. So we can expect two parameters here: the ID of the record we want to update and the changes we want to make to that record. We're going to start our Knex code exactly the same. And then this is where it gets slightly different than how we're used to seeing it within SQL. So we actually want our where statement first. And just like the where on select, we can either pass in an object or two different arguments. So I'll pass in an ID object. And this will tell Knex we only want to work with this specific record. Then we can chain on the update method and pass in the changes object. So once again, this is slightly different than SQL because we're used to seeing the update statement come first and then the where statement comes second. It's going to be reversed in Knex. And of course, just like in SQL, we really want to make sure we do have this where statement, because without it, we're updating every single record in the table, which is probably not what we want to do. Let's test this out. I'm going to run this code. And then in SQLite Studio, we can see that Amy became Candace. Now there's a lot of parallels between this add function and this update. One of those parallels is that if we try to put something fishy in here, it will throw an error. We see almost an identical error here, no column password. Once again, the only thing this means is that you want to make sure that whenever you're using these helper methods, they're wrapped in a try statement. Finally, let's take a look at what this update function resolves to. This will actually tell us how many records have been updated. So if we, for example, got rid of our where statement and ran this again, we'd see the number 5 appear because we've just updated all 5 records in here to have the name Candace. Now, I've given you a lot of information about Knex, about different syntaxes, about what different functions resolve to, but I don't expect you to memorize that, and I don't expect you to automatically know everything you're going to need to do in Knex. So let's jump back over to the docs. I personally find the Knex docs to be really useful, well organized, and easy to read. So we can scroll through and find some of the stuff that we've been working with already under Query Builder. We can see this update function, the insert function, and within each of these are examples of different ways we can insert. It talks about what each method resolves to. Do take a close look though, because sometimes depending on what database management system you're working with, the answer can be slightly different. So this is one mildly confusing part of Knex, but just keep a close eye on it. And if you end up, say, working with Postgres in one of your build week projects, just note that things will be slightly different. So in the spirit of using the docs, you may have noticed that we have one helper function that we have not written yet. And that function is remove. So I'm going to leave you with one final task, and that's to use the documentation in order to write your own remove helper method within this code base. So good luck and have fun.